Hello and welcome to another episode of the Dustin and Eric podcast show, brought to you by Mimosa Networks. Hi, I'm Dustin.
I'm Eric.
And today we're talking about grounding on episode 13, part 2.
Hey, who are these guys right here?
These guys? I don't know. Who are these guys?
They know us already. This is Art. And
I'm Jeff.
And thanks for coming back to the show,
Yeah,
guys.
it's good to be here.
I guess we still haven't scared
guys.
you away yet. Eric hasn't done his thing to scare you guys off. So.
Hey, Art, you're wearing the same shirt you were on the previous podcast.
Oh
How'd
my
that
God,
work?
you were absolutely right. This
Oh
is
my.
ridiculous. This is
We all are.
crazy.
Interesting. So today we're talking about grounding. And so why do we need to ground? Who wants to answer that question?
Well, I think there's a couple good reasons to ground. One is obviously to bleed off any static electricity that can build up over time. And a lot of times we think grounding has to do with, a lightning strike. Let's face it, if you get a direct hit with a lightning strike, your radio is pretty much toast. But what grounding provides over not grounding is the ability for the electricity to have a path to ground, to earth ground, that is. You want to have a wire that has less than 5 ohms of resistance to earth ground. And then most importantly, I would say, is to have ground outside of the building so that it never enters the premise, because static electricity buildup is one thing, but having a near or direct hit from a lightning strike would wreak a lot of havoc on your house. I think we saw some video or some pictures earlier that showed that.
And by grounding on the outside, if you do get a near strike, the bolt of the hit's going to take the path of less resistance, or the shortest path.
That's right.
To Earth.
That's right.
So let's tackle that issue on the outside of the dwelling, the telecom shelter, in the house, or the commercial property.
Yeah, it's definitely a safeguard, because the electricity will follow the least resistance, and so if you have a direct path to ground outside the house, then chances are that electricity is not going to enter the building.
So a lot of customers will use surge arresters before going inside the building,
Yep.
and as it goes out the building, they'll put a surge arrestor in both locations.
Sure.
Yep.
So I mean, the problem with that kind of scenario is that you've got a lot more cabling involved, and you got to do it right in each and every span. So you're dealing with a lot more, potentially more variables that can go wrong, but it's the safest scenario for protection.
So you're looking at protecting all 4 pairs in a network cable as well. Obviously, there's the protection circuit and these NIDs and these other
Like lightning
devices.
arresters, surge arresters,
Yeah,
yeah.
they're looking at each conductor has its own little diode or some kind of protection circuit that'll open up.
But as far as grounding, because I've always heard that you should always have a common ground. But I think what you guys were talking about, that the shortest path to ground, right?
Yeah.
As long as the potential is the same, right, on either end, then it makes sense.
Right.
But if you have different potential, then you want to still find the most common earth ground.
Yep.
Is your better scenario.
So what are some common ground points on, say, a residential
Say a residential, maybe a water spigot, or the copper port where you hook your hose up to water the garden. That most of those, and I guess this depends on local regulations and house and building and all that. Most of that copper, or that's going to be copper all the way to the run to earth. That's one point that you can go. You can put a ground strap on there and go to that.
So you want to know why I asked you specifically, Eric?
Oh, why is that?
Because you have a good video on YouTube about it already.
Oh, we do. Yeah, we do.
So
Yeah.
I think one of the more common questions we see in chat, or at least I know I have, is how do you ground when you're on a commercial rooftop?
Yeah, one of the ways that we do that is to go to, like, the part of the HVAC systems. There's often what's the condenser and the little copper tubes and stuff. And those go to the primary building ground on the outside of these buildings, and so that's one way to get to earth, fairly directional without having a long a grounding or copper line.
So what's one type of metal pipe we should stay away from on commercial and residential premises?
Yeah, gas. Never touch gas.
Pipe, right?
Gas pipes.
But why not?
Well, hey, half the state's on fire right now. Let's play it safe.
Yeah, we don't want any more fires.
That's a great point. Good question. How do you ground on top of a building or in a commercial environment? I mean, that comes up quite often based on our product that our enterprise and WISP solution. We encounter all types of scenarios. So I think that's a very common.
Yep. There's EMT pipe. I guess you can work with your building engineer, the guy that goes up and down the roof that lives in the building on and off site, and say, hey, this is what I'd like to do, and he can point you in a direction.
Or if you have an electrician or somebody that
Yeah.
you can for these kind of things, you may want to hire an electrician.
Those guys know
to make sure the grounding is done right.
Well, they also study and they keep up on, and they know the NEC, the National Electric Codes, et cetera, and the fire NFPA, the Fire Protection Agency Code, and all that stuff.
Also, make sure that you note that pretty much every piece of electronic equipment has some kind of ground lug on it somewhere. Mm-hmm. So if you're deploying equipment in, say, a plastic NEMA box or a metal NEMA box, it has ground lugs on it for you to ground that box. But it also has lugs on the inside for you to ground your equipment to, like your switches and your routers and things like that you're going to put in your box. Your inverters, your converters, anything electrical usually has some way to ground it.
So it would be a kind of a common bonding point.
Right.
And then on the outside of that box, you can go to earth from there, a single point.
Yeah, one thing you have to make sure is the difference between grounding and bonding. Grounding is just what we're talking about here, where you're providing a direct route to a piece of metal that has a less than 5 ohms resistance to earth ground. Bonding is what you're talking about as far as having multiple ground points in a system there. You don't want to just bond and call that ground. You definitely want to make sure that all the bond points come to a common ground, and then from there egresses down to a electrical or earth ground.
So in telecom practice, we usually take a 6-foot tall, 19-inch rack, and it's got individual devices on board. And again, most of those chassis have a little ground screw, so you can take a lug there. And what you want to do, bonding-wise, is each piece will have a little pigtail, and that'll go to the metal rack, the 19-inch rack, with a little 4 or 5-inch pigtail off that device. And then you go to the next device, a couple of rack units lower. Make a little pigtail, that jumper there that goes to the rack, and all the way down for each piece. From there, the rack will go into a halo on the floor, or some kind of a common earth point that goes outside, or there might be a halo or a copper bus bar around the inside of the telecom shelter, for example. And again, those individual racks will come up to that with X gauge, with a very thick gauge of copper conductor. But each individual device has its little short sweep down, and those are the individual multiple bonding points. Right.
Excellent. So looking here on the screen here, we've got just an example of one that took a direct hit, and lightning traveled all the way down the cable inside the house and blew up everything. So this customer didn't have any grounding on the C5, didn't have a NID in place or anything like that. So nothing to even remotely try and stop the surge from coming inside. So Eric,
hopefully, if you take a near hit or a hit, hopefully maybe we can by doing that, grounding all that properly, we can save a piece of equipment or two inside. But more than likely, everything's gonna be toast. You're gonna fry everything up.
Well, if you think about a NID is what, $10, $15, right? So think of it as a cheap insurance policy. I know I've talked to a few insurance adjusters, and the first thing that they look when there's a situation like this where it's lightning strike has hit the house, is they're going to look and see what type of insurance or path of ground has been put in place. If they don't see that, then you may have some issues with collecting the policy money. So
I've seen some where there's a whole blowout like this. Things are properly grounded. They've got a $3,000 AC surge protection system in the rack, and you better be, if you want to collect on that policy, you better
have it in place.
That it's all there in place. Yes,
right. So a quick example is my last place I worked at. We had an installer who put up a similar situation to this here, didn't ground anything, and it got hit by lightning directly, blew it apart, blew the wall out, caught on fire. Actually, luckily they had a fire extinguisher nearby, but because there was no grounding at all, insurance wouldn't pay for it, and they sued the company, and the company had to pay for repairs on the house because of the damage. Because ultimately, since the installer didn't try to do any kind of grounding, it was the company's liability.
The ISP had to pay
Right.
for the. Oh.
Yeah, I don't want to turn anyone in, but I've heard customers tell me that they don't like grounding because it's such a hassle, and it takes extra steps and running cabling and terminating and all that. And I understand it because I was an installer once upon a time. It does take a little extra effort, but think about what you're gambling with. The fact that you're bringing that type of electricity, or in this case, a lightning strike, right into your home. So don't cut corners. I think it's safe to say that.
So another thing, let's say we don't take a direct hit. We want to have that grounding on the outside before it gets in the dwelling for just ESD, electrostatic discharge. Just an antenna, small antenna, large antenna, television antenna, off-air antenna, the antenna on the top of the motor home next to the house. Just from wind, just from the molecules, just from all that static buildup in the air. That stuff's going to collect on a PVC surface or an aluminum metal antenna surface, and it's not going to go anywhere. It might not be able to leak to earth or go anywhere and discharge slowly or fast. And you might damage the sensitive electronics on that PC board inside your client radio or your backhaul radio.
So, Art, how often do you see Ethernet ports blown because of ESD not having anywhere to go?
Yeah.
So pretty common where we'll get complaints from customers about hey, I was working a gig all the time. All of a sudden now it's only getting 100. I can't go higher than that. A lot of times ESD is the main reason why that's happening.
And they check their connectors, and all four
Nothing's
pairs are good.
Yeah.
It's beautiful.
Nothing's
it
changed.
maps out electronically. Everything's perfect. But what happened?
Yeah.
Build
So ESD will be is a common factor as far as the speed negotiation issues that we run into.
So one last thing, Art here manages our documentation. He's got some really good stuff online that talks about this, right? Some grounding and how to do it.
We do actually, yeah. So we're constantly beefing up our grounding and our Ethernet flapping, Ethernet negotiation documentation. So any kind of questions or troubleshooting in regards to Ethernet, please check out our help.mosa.co and just type in Ethernet. You'll get a lot of our knowledge and logic as
Awesome.
far as troubleshooting.
Excellent. So we'll go ahead and end that show here today. If you have any questions about grounding or cabling, feel free to contact support. Feel free to email us at podcast@mimosa.co. We're more than willing to sit down and help you guys out. Make sure you guys have a decent, stable 1 gig connection and a fully grounded system. So with that, thanks Art and Jeff for being on the show here again.
Thanks, guys.
Thank you.
Thanks,
And we'll see you on the next episode of the Dustin Eric Podcast Show. Thanks for tuning in. Please hit the subscribe or follow button to stay up to date with our latest podcast, which will be available on YouTube, iTunes, Google Play, and SoundCloud.